All right, some of you struggled with this combustion problem like mightily. Let's just go over it real quick. So a lot of you are going to want to retake, and that's fine, but you have to watch this video and then do the practice one at the end to get that. So the first thing that you should do, we're trying to find the formula of a simple hydrocarbon that has oxygen. So C, H, and O, and we want to know the numbers that go here. So to do that, we do a series of steps, and it's crunch time. So I'm just going to teach you the short way, or review the short way. You take the grams of carbon dioxide, which is 7.832, and you convert them to grams of carbon. Now, to do that, you take this number. Let's see, this is blocking my way. Whatever, ignore this. You take this number and you multiply it by 0.2727, and that will give you the grams. I'm just going to blow this all up. 7.832 times 0.2727. When you do this, this is accounting for the entire picket fence when we go from grams of CO2 to grams of carbon. That's what that step is for. You end up getting, let's see, 2.133 grams of carbon. Then you do the same step, 1.922 times 0.1111. These numbers right here are always the same. They're the conversion factors to go from grams of CO2 to grams of C, and grams of H2O to grams of H. All right, so you do that math and you get 0.2135. Okay, that gives you the grams of carbon and the grams of hydrogen, but we need to know the grams of oxygen too. To do that, you take the initial number given, 3.489, and you subtract the sum of these two numbers right here, 2.133 plus 0.2135. When you add these together and then subtract it from the initial, okay, so this is the given mass of the CHO molecule. This is how much is carbon, this is how much is H, so whatever the difference is will be what's left over of the oxygen. When I did this, I got 1.142 grams of oxygen. Okay, so the first step is to just convert grams of carbon and hydrogen, of CO2 and water to grams of carbon hydrogen. The next step is to subtract the sum of these two answers from the initial to find the grams of oxygen. Okay, the next major step is to divide each one of these by their molar masses. And those numbers, the 12, the 1, and the 16, come from the molar masses on the periodic table. All right, let's see. When I divided 2.133 grams of C by 12, that gives me my moles, and I got 0.1778 moles of C. When I did this, I got 0.2135 moles of H. When I divided this, I got 0.07138 moles of O. The reasons why I wrote moles each time now is because if I know the molar ratio, then I can know the formula. So once I have them in moles, the next step is to divide all of them by the smallest of the three answers, which was 0.07138. 0.07138, 0.07138. I'm out of room side to side, so I'm going to come down here. When I did this math, I ended up getting, so for my C, I ended up getting a 2.5 For my H, I ended up getting a 3. And for my O, I ended up getting a 1. All right, so this doesn't work because these have to be whole numbers. But it's not too bad. In order to make 2.5 a whole number, I just need to double it. So I multiply every one by 2, and I get 5, 6, 2. And that means my formula is C5H6O2. Now that is the empirical formula. That was the answer to letter B. It was this. Now part C of this problem said if the molar mass is between 190 to 210, 220. Oh, this is such a pain right here. Oh, that's even worse. I have the undo button covered up by my menu for recording. So 190 to 220, it wants to know what the molecular formula is. So what I do is I find the total mass of this piece. So it's 5 times 12, which is 70, plus 6, plus O2, so it's 2 times 16, that's 32. So I got 108. In order to get this number to be within this range, I have to multiply it by 2. If I do that, I get 216. 216 is in the range of 190 to 220, so that would be most likely the correct answer. So I double everything, so C10H12O4. That is how you would do that problem. In summary, one more time. You convert grams of carbon dioxide to grams of carbon by multiplying by this number. Next, you convert grams of water to grams of hydrogen by multiplying by this number. The next step is you take the given and you subtract the sum of these two numbers to find the grams of oxygen. Then, after you have them all in grams, you convert to moles. That's what this step right here was. We convert the moles by dividing each by their molar masses. Once we have that, it gives us the moles of each one. So once we have moles, we divide all 3 moles by the number that was the smallest. That will give me the ratio. So then the ratio was 2.53 and 1. These numbers must be whole numbers, so I had to multiply all of them by 2 to make it a whole number. That gave me the empirical formula, which is the lowest ratio. It might not be the molecular formula. This math only gives me the lowest ratio. Finally, the problem said that the molecular mass was between 190 and 220. So we had to manipulate the mass of our empirical formula to be within that range. And to do it, we had to multiply everything by 2. So our 2 answers are empirical formula and our molecular formula. All right, please do the practice one now.